we have an address on waste to energy. Mr. Vinu, Director X2 Fuels, will shed light on the innovative solutions in this area. I request you to come forward, Mr. Vinu.
Thanks to Anson and the entire Research Park team for giving us the opportunity. Today I'm wearing the hat of our startup company. I'm a professor in the Chemical Engineering Department at IIT Madras. We work on different aspects related to waste to value, waste to energy, waste to fuels. And this is actually an outcome of one of our R&D activities at IIT Madras. So we are X2 Fuels and Energy and Private Limited. Basically, X corresponds to anything that you can convert, any kind of a waste that you can actually convert to value. And that value can be energy, it can be material, it can be fuel, and it can also be chemicals. Okay? So let's quickly jump into what is the context that I would like to set today. See, waste is something that we all know about. We generate it every day, right? On a day-to-day basis, we generate, our institutions generate, countries generate waste, right? And the context that I would like to set is more about a marriage that I would call between waste and energy, right? I'm sure in this Envision event, a lot would have been talked about the energy, the need for energy, the rising needs for the energy of the country, and so on. And this is just another statistics to say that the amount of energy that we are going to be requiring in a decade from now is going to be nearly twice as much as what we are using today, right? And there are projections. I'm sure you would all know about the different projections that say about what is going to be the energy source that is going to contribute. And today we are still thinking about, or we still depend on the natural conventional energy sources like oil, natural gas, and coal. I think that is a fact, right? While we are really aspiring to go towards renewables, right? And that is certainly a possibility, right? But even to do all the innovations, scale up, right? You need energy which is going to be given by the conventional sources of energy. So let us not really park it aside, okay? So I think it's important to really bring it in the context of the energy and whatever materials that we want to make, right? So given that we are actually depending significantly on the conventional sources of energy, right? And on the other side, I'm also showing you the typical crude oil imports of the country. So today we are importing roughly about 4 million barrels per day of crude oil to meet our energy needs, okay? Fuel, materials, polymers, a lot of other applications, but roughly this is the figure, okay? So you can see that, and we are actually, as a country, we are really importing, about 95% of the crude oil from various countries, and I'm sure you would all know about this. So you can say that the price, the crude oil price is significantly fluctuating, right? And you will also see that the import bill is continuously on the rise, okay? So given all this scenario, right, and I've not really come to the waste part of it, right? If you really consider what is this waste all about, right? So today, we generate different types of waste, right? And if I have to put all the waste together as something like a municipal solid waste, right? So these are the numbers, right? The numbers could vary, roughly in plus or minus 10% variation from various reports. But today, this is the typical figure, okay? For example, if you take Chennai, so we generate about 5,500 tons per day of municipal solid waste, right? Out of which you will have about roughly 50% of the biodegradable waste, part of which are being composted. They are recycled, made some value, right? And there is also a significant fraction of it which is going to be plastics and all other different types of components in it, right? Which is going to the landfills. And again, the landfills are getting converted to dump sites, right? And a part of it is also going to some kind of an incineration facility or some kind of waste to energy plants, which are typically, the cement kilns. And I think this is the typical Indian context, right? So if you have to really look at this in a bigger perspective, I think this is not just applicable to Delhi. The Delhi Ghazipur landfill always is talked about. But I think every other metro city has a landfill, right? And the garbage is only piling up, right? If you really look at this whole scenario of waste, right, and are we really having a clear plan of converting the waste to any kind of a value or even energy, right? I would say no. Okay, these are not really done at a very global level. So even if you look at the 500-page report of the International Energy Agency, right, you will hardly see waste to energy being mentioned in just 2 places in a 500-page document, right? So that means there is a huge potential. We agree that there is a huge potential, but because of the heterogeneity and many other aspects, it is not really targeted, okay, towards generating so much percentage of energy, okay, over different years, okay. So what is this waste all about, right? So this is just a snapshot of the waste that we collected and did an analysis. This is from Trichy, right? So you can see that it is not just bioorganic or biodegradable and non-biodegradable glass and metals, okay? The 4 typical classes in which we segregate the waste at our home and dispose it off, right? It is much more, okay? So you can see that, right, a typical waste is going to be composed of too many different components, and remember, all these are actually there in the pile, okay, in the landfills. You have past sins and also the current sins, and also future sins are also going to come up. So the problem is really big, right? So what are we to do about this in terms of converting it to anything that is valuable, okay? So we, as a startup company, we started in 2019 based on some of the early results that we got from IIT Madras, and we work on a technology, right? So I would also like to use this platform to kind of popularize what we do, okay, even though there are other tech, right? So we are trying to actually mimic the nature's way, right? How the nature has been converting a variety of fossil matter into crude oil, natural gas, and coal over millions of years. We try to simply do it on the ground over 15 minutes to half an hour time period, okay? And we do it through a process called as hydrothermal liquefaction, okay? So the process is very similar to this, but all that we do, a bit of technical information is that we try to pressure cook the material or the feedstock, whatever be the waste, okay? Any carbon, hydrogen, oxygen, nitrogen, sulfur containing components, okay? Let it be a mixture, let it contain water, okay? It doesn't matter, right? We really put together in this glorified pressure cooker, as we call, right? And cook it at around 350 to 400 degrees C, okay? And the pressures are typically about 200 bars, right? And when we do this over the ground, okay, typically in about 15 to 30 minutes, right, what we get is an oil, right? And this oil is something that we call as a crude oil or a crude oil equivalent, bio-crude, right? There are many different names to it, okay? But this is basically the fuel, right? We try to mimic the crude oil that we get from underground, okay? We try to make it over the ground using this technology, using the different types of waste we have, okay? So this is the technology component of it. Basically, it says that under these conditions, water really acts as a catalyst, okay? Even if it is a wastewater that is present, right? We have a possibility of processing both the wastewater and also the solid waste in a single mixed form and convert it to valuable products. So what are all the different products? So do we get only oil from this process, right? No, we do get different phases, different product phases. So we do get an oil, which is our key product, right? The next one is a solid residue, just like a coal or a biocoal, biochar, right? Whatever solid residue, that carbonaceous matter that you can talk of, right? So it has some applications in electricity. That's like a low-hanging fruit, but we try to really valorize it and get it converted to activated carbon in such forms, right? We do get gas phase, but again, the gas phase is not going to be composed of any of the typical incinerator gases like NOx, SOx, right? Those kind of gases do not form. It is going to be some amount of CO2, but I'll come to the point that we can still acquire carbon credits by really doing this as a whole process, right? And we get wastewater, which can be recycled, or it can also be used for a variety of these agricultural applications. Okay, the process really stands out. Okay, so it's a feedstock agnostic process. So that means, it's not a process just for biomass or plastic or anything like that. It can be used for any kind of a feedstock, which is something that we have validated in the lab. Right? The process is net energy positive. Typical process efficiencies would be about roughly 60%. Right? Wide applications. Right? As I said, the products have a variety of applications. Okay? So again, this is just data to show that we have been dealing with a wide variety of feedstocks, including real municipal solid waste collected from the dump sites, landfills, right? Some industrial waste. Okay, so these are some of the industrial waste and wastewater combined, put together, right? Lignin, which is a paper and pulp industry waste, and so on. Okay, what do we get? What is the product like? Okay, so this is just to benchmark the quality of the products we get with typical crude oil and diesel, right? So again, we show different types of oil. So if you're going to derive an oil from, let's say, polypropylene or polyethylene, okay, typical plastic packaging waste, okay, because these are made from hydrocarbons, again, we recreate the same hydrocarbons. So we get oils which are of typically good quality from the plastics. If you take an industrial waste oil, okay, which is typically this is a waste from one of the manufacturing facilities near Chennai, right? So we convert this to an oil, and we can actually upgrade it, improve the quality by doing some upgradation strategies, right? We get it close to a crude oil, right? Or if you take a municipal solid waste from a landfill, right? We get an oil of this kind of a quality. So the oil quality varies, right? But we actually know what is a typical range in which the quality is going to be varying. So we can actually propose solutions in terms of the kind of waste that is going to be generated, be it in an industry or an apartment complex or anything like that. Numbers, but basically this is to reinforce the fact that we are today thinking of commercializing the products towards making marine fuels. Okay, that's one of the opportunities. Of course, heavy fuel oil is something that we are already doing, and we are confident of the performance of the oil that we make in the engines. Okay, and there are also some data to show that if you're going to blend it at even 5% to 10%, the raw oil actually gives a very similar performance as compared to 100% diesel in typical diesel engines. Okay. Finally, what is the economics? How does the economics? So this certainly follows the economies of scale. Okay. So we have actually worked out the economics in different stages, right? So I initially said that Chennai generates about 5,500 tons per day, right? So if we have to really target that scale, okay, that means we need to be thinking of something like a plant that would take up about 500 to 1,000 tons per day. Okay, but we are actually at a scale of about 10 tons per day, which is something that we are currently developing, right? And we see that even in terms of the energy price of the oil, right? If you're going to compare the price of the oil with respect to any of the conventional fuels on an energy basis, right? It is certainly comparable with a typical fuel oil or even up to a kerosene grade oil that the refinery is today producing. Okay, our journey so far has been like this. So we still do a lot of R&D in the lab scale at IIT Madras. That's all done by our project staff and students, PhD students, right? We have demonstrated a 100-liter batch, slightly a bigger pressure cooker. We are developing a 1,000-liter per day, which is roughly about 100 kgs per day of a facility which we are setting up in the IIT Madras Discovery Campus in Tayur. And this is actually a work in progress, so we are essentially deploying this in our investors' facility in Avadi, where the industrial wastes are generated at about 5 tons per day. Okay, so this has been our journey, and as I said, if you have to target a typical metro city, right, we have to be talking about something like a 500 tons per day of a plant. Right? Product offering, so crude oil acetate, right? As I said, furnace oil, we have tested that the furnace oil can easily go as a blend with even up to 10% without upgradation. But with upgradation, it can replace 100%. Mild upgradation, right, we can upgrade it to C9 aromatic solvent, which is used by a variety of industries for coatings and adhesives. Kerosene, okay, also as a solvent, in a lot of industries. Even our mosquito repellents have about 95% kerosene. Full upgradation, right? That's the final target, right? We could essentially, potentially make sustainable aviation fuels and some fine chemicals like, BTEX, which are essentially petrochemical products. So we are here currently, right? And we are quite open to, scaling up in this order. So 10 TPD or 20 TPD. And you can typically get about 12 to 18 barrels from a 5 TPD plant and so on for a 10 and 20 TPD plants. Finally, so this is about CO2 savings. I'm sure I have to do a due justification after Rajneesh spoke about CO2 in the previous talk. So our points of comparison are usually, simple dumping, okay, dumping in the landfills, right? Incineration, okay, simple burning, right? And recycling without converting the plastic waste or the municipal solid waste to any other products. So we do actually see a good potential for carbon credit, because the carbon credit market is actually going at an average growth rate of about 30%, right? So HTL can certainly be a very good technology in terms of saving a lot of CO2 that is going to be emitted otherwise. Okay, so we are the team, and thanks to our funding agency, so we are actually located in Research Park in the E Block, and we have a very strong design team with which we are trying to build the concepts for all these different plants and the entire technology together. Thanks for your attention, and I'll be happy to take any questions.